Welcome to Crate and Docker. Thanks to Brian for laying the ground rules, because I think he looked in my presentation in the repository, and mine follows a very similar structure, but with Crate thrown in instead of DigitalOcean. But I'm going to have a few more slides and then some code. So a little bit about me. My name is Chris Ward, also sometimes known in certain places of the internet as Chris Chinchilla, and if you're really interested in knowing the story behind that, you can ask me later. I'm originally from London, but I lived in Melbourne, Australia for 7.5 years, and I'm actually now dual citizen, so I'm half Australian. But I've been losing my accent since I got to Germany. I lived in Leipzig for a while, and then we've been in Berlin for 3 weeks. So this is actually my first talk with Crate. So we'll see what happens, but I brought some of the core team with me to help with the really technical questions, because my programming background is very different. Actually, my programming background, I've been doing 12 years, mainly PHP and then Drupal, which is very different. And I know it's not very cool, but hey, I liked it. In the past, I was a professional musician for 2.5 years as well, and toured the world as a guitar player in an indie rock band. So a bit of history. And I'm developer advocate for Crate, largely for Europe, but also a little bit of rest of the world. Nice to hear, rest of the world is not Europe, isn't it? Here's my contact details if you want to stay in touch, but we've also got the contact details for the company a bit later. So I do love open source. First of a couple of silly animations. Aside from working in open source community and software for a long time, I'm also working on an open source work of dystopian fiction and an open source board game. So I like open source in all its flavors. There we go. Here we go. Okay, this will be the last silly animation, I do promise. So we're going to make the first big bold statement of the night. The single node database is dead or dying. I don't think anyone runs their databases on this anymore, but if you do, then I'd be quite worried. So the justifications for this statement are, there we go. It's supposed to set on fire. There we go, right. Justifications for this statement are that the availability, the resilience, the elasticity, and the amount of data we are now storing in our applications is done to make this structure dying, if not dead. So, second big statement is we feel that the future of databases is distributed. We're probably not the only ones, even in this room, that think that. And we share this opinion with many larger companies, of course. And this is how we feel that data or backends for our modern application structures will be moving. And here's, this slide is borrowed and adapted slightly from Adrian Cockcroft, who's ex-Netflix, and I have the link to the post in the presentation if anyone wants to know. It's kind of where we've been, but also where we are, where we're going, and the future of our microservices and application setups. And aside from these benefits I've already mentioned, the new distributed structure is also about reducing those silos of information within companies or skill sets that are needed for quick deployments. We can't have a quick deployment because there's been a spike in traffic if the guy who knows how to set up the data center is on holiday. So these sorts of infrastructures are helping us get around those blockages as well, not even technical blockages. Some of these older setups worked with the old style monolithic applications, but not so much now with the trends in microservices, multiple languages, multiple applications, multiple devices, all feeding to and from a data set. So at the moment, how do we start building our complex applications? Generally, we probably start with something like MySQL, and then as our usage scales, we have to start worrying about things like sharding, setting up master and nodes, replication, synchronization, etc., etc. And then, as this becomes more complex, we need other requirements. We need a document database, so we add a document database. We need a blob database, so we add a blob database. We need search, so we add search. We need a better search, so we add a better search, and etc., etc. This is fine and great. But again, when it comes to coping with an upsurge in interest, how do we easily scale that? How do we change that without just losing sleep over these synchronization solutions? It keeps a lot of us up at night, and I think we sometimes enjoy it, but I know we'd rather spend our time on other things. So, bearing all that in mind, traditional databases on Docker. There are many solutions to keeping our data in, I've completely forgotten the word I need. Persistent, that's the word. When we start adding extra database containers and application containers, there are, of course, ways to keep the data persistent amongst those new instances, but again, it involves potentially complicated processes, potentially time wasted when we could be improving our application, our software, our product, our customer service, etc., or just having fun. So that leads us to what we're hoping or are doing. Crate. Crate.io is the company, Crate is the product, just to clarify. So the product, I keep saying product, it's actually open source, I should stop saying that. It was initially started in late 2010 in Austria. This is why we have lots of mountain imagery. It's born out of Austria. And we initially looked at Elasticsearch and really loved how easy it was to scale it, how easy it was to use, and the modern architecture behind it. So initially we started developing plugins, but then quickly realized that actually we could do more. So started instead building a distributed database that has become Crate. So a couple more slides and then we'll get on to some examples. What is Crate? I guess our summary sentence is it's an easy-to-use distributed SQL database to build applications that are hopefully worry-free and services and at scale. It's perfect for containerized and distributed environments or ephemeral environments, such as Docker. Not limited to Docker, but we work very well with Docker. We have ready-to-use SQL and ORM, object relational mappers, if that's what you're used to. And I guess one of the unique points that we feel in our architecture is this all nodes are equal concept. There theoretically is no master node, slave node. Every node has the same, can do the same functionality, performs the same roles, and are independent of each other whilst also being aware of each other. This makes the horizontal scrolling very easy. You just add another one, and it's exactly the same as the last one. Add another container, add another node, and so on and so forth, without having to worry about delineating what roles they have in this growing cluster. So that's one of our main points of difference. The other is moving the data around, the persistence, as I've mentioned. So, enter Docker and cue initial silly demo. So, I will actually jump into this, even though this is all probably fairly familiar, and I will attempt Brian's trick. Let's see. Now, I've also remembered the annoyance of Keynote, but everything's split across two screens. Okay, I'm actually going to use here, I'm going to use Kitematic, which is, I guess, Docker's sort of recommended installer for the Mac. It's actually not completely there yet, but it's very good for demos because we're not just looking at command line, we can visually see things happening as well. So I'm just going to be using it for demonstrating what's going on. So let's start with something fairly familiar. I made sure I had everything locally first, but we'll see what happens. I also have to do this backwards. Oops, yeah. Good start. I don't know what carrot is, but I'm sure it's very good. Okay. Yeah, it was already there, so that didn't take very long. And I'm going to run the docker run command 3 times, and then I'll explain why. You can see the third one is slightly different. Okay. So now if I switch into Kitematic, we'll see the 3 containers there. And just to show, we have a very cool admin UI, which is not that or that. It's this. I'll just refresh to get the actual current ones. And we can see up in the near top right-hand corner, nodes 3. And this is our default admin UI that comes straight away with Crate. Gives you an overview of everything. Get started, which we'll do. We just have a Twitter import to get you started with data to play with. This is on my local machine, which is not the best optimized, so it's not the speediest setup, but we'll get onto something far more superior soon. So I'll just import a few hundred. Okay. If we come down, we can see our tables overview, shows the schema, and total records, shards, etc., etc. Our cluster, at the moment, as I say, we have 3 nodes, some details about those. And I'll jump back to the console where we can issue some. So firstly, very simply, oh yeah. Have you not heard of Twitter? Oops. Typing backwards is quite difficult. There we go. And as you would expect there, we get just a list of all the latest tweets pulled in. So let's try that, something slightly different. Again, not much going on there, but shows you how few Twitter users are verified, which is something, a whole other discussion. And so to explain those commands that we issue in a little bit more detail, so what we've done is we've created 2 instances and let Docker do the port binding to its range. And then we've bound the 3rd one to our set ports that we use for Crate. And then because Docker on local is multicast enabled, they just pick each other up. And because we've used these ports already, of course, if we want to add more containers, we keep using the first command over and over again to add more. So that's a very, very simple example. That's great, but alluding to what Brian said earlier, so what? That's not particularly useful, is it? So let's jump into something a little bit more complicated. And again, I'm going to jump into a demo. I'll show you sort of the end result. I'll jump into a demo, and then we'll explain some of this. So. And I do apologize, DigitalOcean, you get a plug later, but I'm going to use AWS for a minute. I'm going to do the idiot. So this is our bigger cluster set up on AWS, and the internet is, oh dear, hello. I think that's okay. Let's double check. Okay. Any speed issues, I'm going to blame the internet, not us. Okay. So here's an idea of what we're looking at. We're looking at a 12-node cluster, just a shade under 660 million records, which is a fair amount. The table structure we have. This is an emulated step tracker for users. So this could be information coming from people's phones, feeding back to phones, but stored in a centralized database. Maybe stored in a distributed database. Maybe there's a web login as well, etc., etc. So here we have our steps table itself is 50 gig, and here's an idea of some of the partitions and the schema. Very simple schema, but very large. So this is a lot of information. let's try some queries. So the first one I'm going to try is a histogram of steps per day for a single user. So they're pulling it up on their mobile phone and they just want to see how many steps have I walked. So that took 0.011 seconds to query quite a lot of data and get a result. Okay. Let's try something else. This is the number of steps they've taken each day in a month. Took a little bit longer. Took an extra 7 milliseconds, I think, yes. But there we go, we can see our data set there. Okay, very well and good. We're proving that it's reasonably speedy, but what else is there? Okay, I'm just going to log in to the instance, okay. And unless anyone else has been using this, which I don't think they have, I can just use history, which is useful. So this is a 12 instance cluster of AWS servers. So I'm on one machine. I can see, I'll move that up. Ah, yes, I've forgotten one step. So we can see this instance of Crate running on this AWS instance here. So what I'm going to do is I'm going to kill it. So we had 12, remember? Second, and if we jump back, we'll see we now have 11 nodes and slowly the health indicator is changing. Now, as this is my first talk, I want to make sure I tell you exactly the right thing. So I'm going to explain what is going on there. Now, of course, I've lost mirroring. So data is rebalancing, resharding, and resynchronizing to be replicated across all of the existing nodes. And if we added one back in or another one back in, the same thing would happen again. But just to point out, it is all still available. It's all still current. A query will still give you the same results, etc., because we have enough redundancy in the cluster to cope with that. So. Okay. So just to point out, break down this command a little bit more. We've seen the first line already. The second line is probably reasonably familiar if you've used Docker that much. We're setting the data store. So this is how we can make it persistent across all these instances. We're setting a heap size. And then we have, these are specific crate configuration options, and we have a fair amount available. And these three at the bottom are the ones that are making a lot of this possible through using unicast. So, and we have a lot more detail about some of the process behind this on our blog, but we can answer some more questions after the talk as well, if that needs some more explanation. Okay, so that's great. What if you're a developer? You could use curl to just query the backend and do all sorts of wonderful things, but we also have a lot of client libraries to support you. Here are our official ones: Python, PHP, Node, Java, Ruby, all open source again. We also have some community contributions in Mono, Go, Erlang, also Java with Spring Data as well. And I'm going to show you a very, very, very quick and silly, well, not silly, but just not very complicated Node example, just to give you an idea. Someone needs to make presentation software that lets you. Okay. So this is a very simple example of a Node application that queries the tweets database we had already, sets up a connection, and then just runs a very basic query and outputs it to error log. I mean, it's obviously not taking any advantage of Node.js whatsoever, but it's just an example to show you that it's reasonably straightforward to start running the queries. And of course we have functionality for writing, dropping, altering, all the other sorts of database type operations you'd expect to want to do. Okay, so what about some of the other tools that Docker has in its tool set? How do we work with those? These will vary in, some I'm going to demo, some I'm just going to explain. So Compose. So Compose, I think Brian's already explained it, but it's a way of defining your application's components into a single file, and then you can use the one command to get everything up. So just an example of replicating some of what we looked at already with crate in a composer file. You can probably recognize a lot of what we've already got here, the ports, the volumes, environment variables, and then when we want to send specific configuration options to crate, we override the default command. That's pretty much the only extra complication beyond normal composer. So pretty straightforward. Machine, I saw DigitalOcean Responser, so I thought I'd give them a plug as well, and they gave me a hoodie, so my work here is done. I thought I wouldn't chance the internet, so I made one earlier, but the command is reasonably similar, and you've seen Brian doing it already, but Docker machine create, select the driver, put in your token, give it a name, switch to it, again, issuing the normal crate commands we've already seen, and I'll just approve it. I'll show you my personal DigitalOcean account. I have actually been a very happy customer for a very long time. There's the instance there, and here it is running there. It's not a particularly complicated one, but there it is running. And I'm not on their Frankfurt data center, so it's a little slower. But that was as simple as issuing the machine command. Okay. Now, Docker Swarm. Docker Swarm is a little bit more complex. And so I have backed out for this time, and I'm going to direct you to a blog post in the interim to show you how to get crate working with Docker Swarm. It is perfectly possible. It requires a little bit more configuration because you're setting up a distributed cluster, but it is possible. And here's a blog post. I'm sort of just getting the hat trick of sponsorship mentions. It's actually on Google Compute Engine. I just need to have another one in for a different service, and then we're done. But so here's a blog post you can see about getting Swarm working with crate. And next time we come back, I'll have a nice, fully functioning demo for you. But we thought we'd keep it a little bit quicker for this presentation. So finally, after we've sort of wrapped up what it is and how it works, what's it good for? What's it usable for? So we feel that crate is perfect for high volume, semi-structured, dynamic data, data that changes all the time. I guess some of the perfect applications would be things like Internet of Things, wearables, lots of marketing and analytics type data. We feel that it's perfect for startups or organizations that start with 1 or 2 team members and then grow without knowing when they'll grow and how much they'll grow. It's very, as you can see, it's very easy to get clusters up and running, and then just focus on building your application. And alongside alongside Docker with any of the languages you're using also in containers. We feel that at the moment it's a good drop-in replacement for all of our much bigger competitors like MySQL, Mongo, Cassandra. That's the positives. What about what's it not suited for? It's not suited for systems that require strong transactional consistency, like financial information, I lost my train of thought there. I'll just forget that one. Or strong relational data. We have some relational capabilities, and here's where I put in the little asterisks. Joins are coming in June. But that still doesn't mean that we'll be well suited to strong relational data or strong transactional consistency. But if you're working in Internet of Things type startups, or just lots and lots and lots of information that comes from all directions and will be changing all the time, absolutely perfect. So that was me, my first presentation. I hope it went okay. Here's some of the ways you could stay in touch with us, and we can even be more old school. We're in Berlin, 4 of us are anyway, in Beta House. So if you want to come and just have a chat, you can do that as well. And here is where I ask that dangerous question. Any questions? Okay, I'll see how I go.
Do they support geospatial searching?
Yes. Actually, that's one that should be on the feature list. Yes, it does. Yes.
How many instances can die before you actually use data?
Do you guys have any more?
Depends on your replica set. You can configure your replica set, and depends on how much
So you can configure like how many copies of
yeah, you can configure that.
So the question was, how many
instances?
Yeah, how many instances before you start experiencing data loss? Yeah, and the answer was it depends on your data set, but quite high is the yeah, and it depends on the replicas as well. But we have clients running very large instance sets and data sets and have been okay. So.
Yeah, sure.
Time series data, yes.
That's the partitioning table Chris showed for partition by day, for example.
The petitions showed in the AWS example. The conversation is continuing.
Stream, directly stream.
Yeah, milliseconds,
You mean you want the stream input?
Yeah, stream
So streaming is in media streaming, or time series streaming? Okay. Okay. So no. Okay. And one at the back.
Am I correct in understanding the underlying data store is Elasticsearch?
No.
Bits of it.
We are using Elasticsearch, but we store directly to Lucene, and we are using from Elasticsearch. We are using some parts of it, mainly for sharding and replication and stuff like that, and the transport protocol also. But we started with plugins for Elasticsearch, and at that time we were only a layer on top of Elasticsearch. But now we are more deep in replacing Elasticsearch parts with our own implementations. For example, we started with aggregation support. At the time we started implementing aggregation support, Elasticsearch didn't have this. Now they're supporting it, but they're supporting it in a different way. For example, they cannot do accurate aggregation. You can do this for a long time. And we are also distributing our aggregations. As far as I know, Elasticsearch is still aggregating on a handler node. So you're just using the memory of the handler node for the whole aggregation. Our aggregation implementation is using the whole memory of the whole cluster for doing the aggregation stuff.
The summary answer is on this slide. This is for anyone who didn't hear that. We are relying on Elasticsearch and several other components, and added some of our own as well. And probably most of you had time to read this during that.
So the accurate answer is we are using Lucene for the storage layer.
Okay.
Which is Elasticsearch is also using.
So I guess my maybe follow-up question would be, can you say a few words about your consistency and durability guarantees in the face of partition?
Yeah, we're expecting this.
These are the two questions we were expecting.
We're suffering from the same things like Elasticsearch, and we helping Elasticsearch are close together. Elasticsearch is doing a great effort currently in solving these issues, and yeah, we're suffering the same issues. But to be fair, maybe a lot of people don't know, the tests you're mentioning, the FI tests, I think almost any database is failing this test, not only Elasticsearch. It's not an accuse, but it's a hard challenge to solve, I want just to mention.
I agree.
See, I had the blog post, their webpage open in anticipation of the questions around Elasticsearch. Yep. So we are working with them as well in helping solve some of the issues they experience, but again, we have not experienced any of those issues on our installations and clients using Craig. So that's a question.
Multi-data center awareness, is that something you're looking
In terms of providers or?
yeah, to support?
Yeah. It's, we have documentation and tutorials on AWS, SoftLayer, Google Compute Engine, and soon there'll be, it's also possible to pretty much install on any other, but they're the three that we have everything set up and showing you how to do it, and instructions and more simple steps also coming for Azure very soon, and also very soon we're going to have one-click deploy on Google Compute as well.
The question was more to do with that I have a set of nodes in one data center.
Oh, okay.
I want to replicate.
Sure, yeah, we can do this. You can configure data center awareness and configure also that to be sure that one replica set is also always replicated to the other data center. You can do all the stuff, yes.
Data center replication, yes.
How do you make money?
No, that's not the question I completely know the answer to, but at the moment we have some, I haven't been told I can't say this, so at the moment we have some VC funding and we have premium plans for people who require that, and we have some clients on those premium plans. So yeah, it's startup structure. Yeah, I think there's a person who's had their hand up here several times and I kept missing them. No, okay. Anybody else? Well, come and have a coffee in Beta House. Yep. Okay. Thank you very much, and thanks for being with me for my first talk with Craig. We have some stickers. Ignore the DigitalOcean stuff. We have some stickers over there. And thank you very much.